Hey everyone! Ever wonder how your phone's GPS knows exactly where you are? Or how video games build these massive, incredible worlds you can explore? Well, the secret sauce behind all of it is a super powerful math tool called coordinate geometry. It's basically the language for describing any location, and today, we're gonna get fluent. Let's dive in.
So let's think about it for a second. If you're trying to meet a friend at a giant concert, just shouting, "I'm by the stage," well, it's pretty useless, right? You've got to be way more specific. So what's the trick to giving a location that nobody can get wrong?
Exactly. It's just like finding your seat in a classroom or a movie theater. You don't just get a row, you also need a column or a seat number. Row 3, seat 4. That leads you to one and only one chair. This simple idea, using 2 reference points, is the bedrock for everything we're about to do.
Okay, so here's our roadmap for today. We'll kick things off at the basics of locating a point, then we'll build the famous Cartesian plane from scratch. After that, we'll learn the lingo of coordinates, get our hands dirty plotting some points, and then wrap up with a quick summary and a bunch of practice questions to lock it all in.
So we get the real-world idea, but in math, we need a system that's totally universal, a system that works the same way every single time, no matter what. So let's see how that came to be. And for this brilliant system, we have one guy to thank, the French mathematician and philosopher René Descartes. See, back in the 1600s, he had this incredible aha moment that connected geometry, shapes, with algebra, numbers. It was a total game changer, and his system was so good, we still use it today. It's even named after him. And this is it, the Cartesian system. You'll also hear it called the coordinate plane, or the XY plane. This definition right here is the absolute heart of the chapter. It's just a fancy way of saying we use 2 number lines that cross each other at a right angle to make a perfect grid. And with this grid, we can nail down the location of any point with 100% accuracy.
So how do we actually build this thing? It's way easier than it sounds. Let's put one together right now, step by step. First, we lay down a horizontal number line, the kind you've seen since elementary school. We call this the x-axis. Next, we draw a vertical number line right through the 0 on the x-axis. This is our y-axis. That special point where they meet, we call that the origin, and it's our home base, 0, 0. You can see that these 2 lines split our flat surface, our plane, into 4 distinct sections, and we call those the quadrants. Now, each of these quadrants has its own simple rule, based on positive and negative signs. Up here in the top right, quadrant 1, both x and y are positive. Then, if we move counterclockwise to quadrant 2, x goes negative, but y stays positive. Down into quadrant 3, they're both negative. And finally, in quadrant IV, x is positive again, but now y is negative. Getting this pattern down is a massive shortcut for your exams, trust me. Every single point on this grid has its own unique address, just like every house on a street. And in coordinate geometry, that address is a special pair of numbers called coordinates. Let's break down how to read them. Okay, time for some vocabulary you will definitely see on your tests. The x-coordinate has a fancy name, the abscissa. That's its official title. It tells you how far to go left or right. The y-coordinate is called the ordinate. That tells you how far to go up or down. I know, they sound a little weird, but just remember, abscissa, then ordinate, x, then y. All right, listen up, because this is probably the #1 spot where people make mistakes. Coordinates are called an ordered pair for a reason. The ordered part is absolutely critical. The x value, the abscissa, always comes first. Always. Look at the screen. The point 4, 2 is a completely different spot on the map than the point 2, 4. The order is everything. Okay, enough with the theory. We know what the grid looks like, we know the language. Now let's do something with it. Let's take a coordinate address and actually find it on the grid. This is called plotting a point. So let's plot the point 4, -2 together. Rule number 1, and you can't forget this, you always start at the origin, right there at 0, 0. Our first number, the abscissa, is a +4, so we move 4 units to the right along the x-axis. 1, 2, 3, 4. Okay, now from that spot, don't go back to the origin. From right there, we look at our second number, the ordinate. It's -2. Negative means we go down, so we move 2 units straight down. And boom, you mark your dot. That's your point, 4, -2. Whew, okay, that was a good bit of information. So let's just hit pause for a moment and boil it all down to the key takeaways. These are the things you absolutely have to remember.
So let's recap. We've got our Cartesian plane made of a horizontal x-axis and a vertical y-axis. Where they cross is the origin, 0, 0. Every point gets a unique address, an ordered pair, x, y. Remember the fancy names. X is the abscissa, y is the ordinate. The plane split into 4 quadrants, each with its own plus-minus sign rules, and a couple of pro tips. Any point sitting on the x-axis has a y-coordinate of 0, and any point sitting on the y-axis has an x-coordinate of 0. Got it? Good. All right, knowing the rules is great, but the only way to really get good at this is to practice. So it's time to put what you've learned to the test, with some questions just like the kind you'll see in your exams. Let's start with a few easy ones to warm up. These are to check if you've got the basics down. For example, what are the coordinates of the origin? I'll give you a second. If you said 0, 0, you nailed it. Okay, let's turn it up a notch. The medium questions will make you connect a couple of ideas. Here's one. A point has a negative abscissa and a positive ordinate. In which quadrant does it lie? Think back to those sign rules. Negative x, positive y. That's gotta be quadrant 2.
And finally, the challenge round. These difficult questions often have multiple steps. They really test if you understand the whole picture. So for this one, you need to plot all 4 points carefully, connect the dots, and then use your geometry knowledge to name the shape that appears.
As we wrap this up, I want to leave you with this quote from the great mathematician Paul Holmos. You can watch 100 videos, you can read 1,000 pages, but the only way to truly learn math is to do math. So take these ideas, dive into those practice problems, and make this knowledge yours. You can do this.